Okay. So we continue with hash puzzle to prevent double spending. So we said that the system is decentralized, but if the system is decentralized, they have to be synchronized at the same time, right? And a few second differences might cause a lot of problems. So we have to prevent double spending by kind of slowing things down, right? This is done by proof of work consensus method. So idea is as follows. Instead of recording every transaction on the blockchain, let's try to gather them together and compute a hash of it. And if somebody calculates the hash that is smaller than a predetermined value, let's say that he is the winner of this competition, and let's record only those transactions that he included in that hash. Okay, so that is the idea. So whenever you say that, whenever you're using a wallet application and create a transaction, you actually announce it to the network, but it is not performed yet. Okay, it may never be performed if you, for instance, if you are not paying fees. Nobody will include your transaction in the blockchain. But most probably somebody will include it just to earn the fee from that transaction. So in average, in 10 minutes, it will be included in the block. Some miner will use those transactions with all of the other transactions. So we have to go back here. So what they do is as follows. They calculate the hash of all of these transactions, calculate the Merkle root, then take another hash of this system, but this time, so they of course have to include Coinbase here. They calculate the Merkle root, then take the hash of this header and see if it is smaller than some value. If it is not, they modify the nonce. So they modify the nonce for every value, and people think that this is the hashing, but actually, sorry, this is mining. So they think that mining is only changing this nonce value. But this is meaningless because this nonce is actually 32 bits. So there are 2 to the 32 different nonces you can use. And using a GPU, you can try all of them in a single second. So assume that you heard some of the transactions, computed this Merkle root hash, then try all of the nonces in 1 second. Then what you do, right? You spend everything. So you have to change something else. Actually, there are a few things you can change. You can change the order of the transactions if you prefer, but mainly you have the Coinbase transaction that is unique to you, right? So you can change values there. But if you change this part, then you have to take all of these hashes again, calculate the Merkle root again, and then try all of the nonces again. So actually, mining is not trying all of the nonces here. Actually, it also includes changing values in the Coinbase transaction. Okay, so this is how the mining works. So we have a difficulty, and that is just a number. So you try to find a hash value that is smaller than that number. This means that some initial bits of your hash output has to be 0. So if you go to the example block, you can see that this is the hash obtained by the miner. You can see that there are a lot of zeros here. And this is in hexadecimal notation. Every 0 here actually corresponds to 4 0 bits, right? So you have to count the zeros here and multiply it with 4 to see how many zeros it contains. So this is how they sort it. And you can see that Merkle root is here. This is the Merkle root of all of these 3,000 transactions. And this is the nonce value the miner used. And as you can see, the size of the block is more than 1 megabyte, as I told you. So you might think that this contradicts the idea that a Bitcoin block cannot be larger than 1 megabyte, but actually, due to SegWit update, we virtually increase this number to 4 megabytes. Okay. And here is the transaction volume. In this block, people spent 27,000 Bitcoins. Okay, so this actually, I took this screenshot from December 14, just before giving a talk. So it is kind of a recent blog, but you can go to this web page, which is actually contains all of the Bitcoin blockchain. So you can see at which block what happens. So you can see these values. Again, here you will see the version number here. This is actually the Bitcoin software they're using. So whenever you create an update, So these numbers actually change, and some miners update those values before even that update becomes effective. So that this means that they are going to use the new version. Okay, so this way we can understand if the whole miners will agree with us in the future. So this version number is also important. Height means the number of the block. Timestamp is here, and so on. So this explains almost everything that we talked so far. Okay. Yes, so if we go back, so one of the problems is that so you're constantly calculating hash values, so you're spending electricity, and people think that all of the work is wasted, right? You're just doing calculations just to obtain a value like this, and all of the remaining computations doesn't contribute to anything, so they are lost. So this is why some people are not happy with this proof of work concept, because we are actually using a lot of electricity. So let's talk about it first. So first I have to say that not all of the work is lost, because nowadays nobody mine by themselves, because it is very impossible to mine Bitcoin with yourself. So you have to join some of the groups. These are called pools. So people join together as miners and gather in those pools. And even if you are not the one of the people in that pool that finds the hash value like this, if you prove that you tried to find it, then you will earn some amount of Bitcoin. So how you can prove that you are really trying to solve this problem? So even if you cannot find this many zeros, maybe you can find something smaller than that. This means that you are really trying to find the solution. So in the pools, all of the miners actually send their shares, which are, which doesn't solve the whole problem, but actually a smaller version of it. So this way, not all of your work is lost. You kind of prove that you are really trying to solve. So miners prove they are working by providing hash values slightly larger than the target value. That is the whole idea. So I took these numbers probably in December, so probably they are increased a little bit, but let's look at the electricity consumption. Bitcoin mining's yearly electricity consumption is around 200 terawatt hour. So this is actually an assumption. We cannot actually be sure what is the real value, but depending on the mining hardware that people use, we can somewhat estimate this value. And Ethereum is almost half of it. In Ethereum, generally people still use GPUs, but in the Bitcoin, you can only use ASICs. CPUs or GPUs cannot compete with them, and we will talk about them when we're talking about mining. But as you can see, many European countries actually spend less electricity than Bitcoin mining. So this is a concern by a lot of people. In my opinion, these numbers are not that huge. For instance, in the United States, devices that are plugged in and are not used actually spends more electricity than this. So it is not that important for me right now. But more importantly, last year around this time, this number was like 80 terawatts per hour. But recall that during the pandemic, and thanks to Elon Musk, people got interested in this kind of stuff, and a lot of miners joined the system. And you can see the terawatt hour chart throughout these years and see that this number increased in the last 2 years significantly. So if it stays at 200, I don't mind, but maybe when I teach this course next year, this number will be 400. So that is a huge problem. So if new miners join the system, the electricity consumption increases, but there should be a reason for new miners to join the system, and this happens when the price increases. So an increase in price of Bitcoin or Ethereum actually results in more electricity consumption because more miners join the system. Okay, so we should look at the problem in that respect. Okay, so this is the main idea behind the electricity consumption. You are trying to solve a hash puzzle, but this is only a consensus model that we call proof of work. In different consensus models, you don't have to spend this much electricity.